In this practical tutorial, we will implement a simple REST API for managing users stored in a Mongo database, as we did in the previous Node.js tutorial. For this purpose, we will do the same exercise but using the Deno runtime instead of Node. As you may know, Deno was created by Ryan Dahl, who is the same guy that created Node. Deno is built in the Rust language and was conceived to be a better alternative to the Node.js runtime, as it's a simple, secure and modern runtime for JavaScript and TypeScript that works on top of the V8 engine that uses the Chrome web browser. The programming language of Deno is TypeScript, which is used in frameworks like Angular or Ionic. Since TypeScript is a subset of JavaScript, it means you can also use JavaScript code when programming in TypeScript. In the official webpage of Deno at deno.land, we can find the installation instructions according to our operating system. To accomplish the purpose of creating a REST API with Deno, we will use a third-party module named OAK, which is based on the Koa framework for Node.js. Deno comes with a basic set of standard modules. Among them, there is the format module that allows rich text strings formatting or the HTTP module for managing HTTP connections, to just name a few. Despite being a young technology, Deno has a large amount of third-party modules already created by its growing community even before the release of its first stable version. First of all, we need to install the Deno runtime in our computer. You can build and install Deno from scratch, downloading its source code written in Rust, or you can try the easy way, just installing the proper build version according to your operating system. As I'm working on an Apple computer, I can install Deno using the brew package manager with the command brew install Deno. Since this tutorial is intended to be made using the latest release candidate version, prior to the stable version 1.0.0, I was forced to make an upgrade with the command deno upgrade. Before start implementing our REST API server, let me show you an interesting thing you can do with Deno. I will try to run an application hosted remotely just using its URL. This sample application is provided by the Deno website just for demonstration purposes. To run an application in Deno, you can use the command deno run followed by a local file name or a remote URL. In this example, Deno first downloads the source code of the application, compiles the code, and then runs it locally. Deno stores the source code locally once a module or application is downloaded. So, if you want to force Deno to download the source code again, you can use the command deno run --reload followed by the application file or URL. I want to clarify that the compilation of a program in Deno basically consists in transpiling the code written in TypeScript to JavaScript. Being said that, now let's begin with the implementation of our REST API for managing users. First, create a folder for the project and import it to your favorite IDE or source code editor. Next, create the file server.ts that will be the main file of our application. This file is intended to be used to create and use an instance of the API server class that we will implement later in TypeScript. Through the parameters of the class constructor, we pass an object containing the host name and port where we want to our server listen. Finally, we start our server by calling the method startServer. Now create the file apiserver.ts inside the source folder in the root of the project. This file will implement the class API Server. The API Server class will be in charge to open a socket and process HTTP requests. To avoid implementing all the logic related to connection management, HTTP parsing, or the routing rules from the scratch, we can use any of the existing third-party modules available in Deno to easily reach our purpose. Deno have a third-party module named OAK that is basically a simple port of the Koa framework that is also based on the Express.js framework. We can import this framework just entering the URL of the module in the import section on top of the JavaScript file. In Deno, there is no need to use a package manager like npm anymore, so the dependency management is completely transparent. We will use the format standard library that comes with Deno to print rich text logs on the screen. To tell OAK to stop the server, we need to use an abort controller object that allows you to abort one or more web requests when desired. When OAK receives an abort signal, it closes any active socket connection and stops listening for HTTP requests. OAK, like many other web frameworks, uses something called middleware. Actually, the term middleware is most commonly used for software that enables communication and management of data in distributed applications. Despite that, in the world of web frameworks, a middleware performs some specific functions on the HTTP request. In the day-to-day, a middleware has become a design pattern to allow server logging, handling authentication, or gzip compression without having large chunks of code tightly coupled. Middlewares are used in a myriad of popular web frameworks like Django, Express.js, Spring, PHP Laravel, or Ruby on Rails, to just name a few. In order to get high precision timestamps to calculate the time spent to process a request, I use the native function performance.now, which provides timestamps in milliseconds and microseconds. The init-logger method implements a simple middleware to log all the HTTP requests received. Our logger will print on the screen all the information related to each request received. As you can see, the parameter context is the object that is passed from middleware to middleware. The parameter next is a callback function used to execute the next middleware in the stack. Okay, now let's try to compile and run the application we made so far with the command deno run server.ts. Fix all the syntax errors that may appear and try to compile and run again. At last, Deno will give us a permission denied error due to forbidden access to our computer network interfaces. It doesn't matter if you run the application as super user. This happens because Deno runs in the sandbox mode. It means that any access to a system resource is denied by default. This is intended to be made for security purposes, to avoid undesired access to our computer from third-party dependencies. Deno has a list of available command line flags to enable access to certain resources when we run an application. To finally run our HTTP server, we must run the application with the command deno run --allow -net server.ts. To ensure that our server is working as expected, we will make an HTTP request to the port 8000 at localhost from the web browser. Our server should respond with a content not found response because we didn't specify any endpoint yet. Now we continue with the specification of all the endpoints we want for our REST API. Let's begin with the endpoint to fetch the list of all the users. Later, we will implement the persistent layer. Meanwhile, our API endpoints will just deliver empty or fake data. To test or debug our endpoints, we can use the web browser or an HTTP client like Postman. Once we got all the REST API endpoints defined in the API server class, we will start implementing a new TypeScript class named User Manager to manage the user's data using a Mongo database as persistence layer. Now create the file usermanager.ts inside the source folder in the root of the project. This file will implement the class usermanager that will provide all the necessary methods to create, update, get and delete users from the Mongo database. Deno have a third-party module named Mongo implemented in Rust that provides an interface to easily interact with the Mongo database. As I explained it before, in Deno we can import third-party modules just using the URL of the module in the import section of our TypeScript file, so there is no need to use a package manager like npm anymore. You can easily browse the source code of a Deno module just opening its URL in a web browser. Okay, now let's begin defining some TypeScript interfaces and other needed structures. Before start implementing the code to connect to the database, first launch a Mongo database in your computer. If you need some help regarding how to install and launch a Mongo database, please feel free to check my previous tutorial I made explaining how to create a REST API using Node, Express, and MongoDB. You can browse your Mongo database using a client application like Robot3T. Next, we need to implement the method connect with options in order to open a connection to the Mongo database. Now it's time to implement all the methods we need to perform the proper write and read operations against the database. Every method call to the user manager class instance that involves reading or writing data to the database will return an object with the status code of the operation and the data involved in that operation. The status code of the operation will also determine the HTTP response code of the HTTP request. Once we finished with the implementation of the endpoint to fetch the list of users, we can compile and run the server to test it. After fixing some syntax errors, Deno will give us another permission denied error. In that case, the error will be due to providing access to written rate data. As I explained before, Deno runs in a sandbox mode, so any access to a system resource is denied by default. To allow our application to read and write data, we must run the application with the flags allow-read, allow-write, allow-plugin, and unstable. As you can see, the output logs that prints our server show durations with the precision of milliseconds instead of microseconds. This is an acceptable time precision, but not enough if you want to debug your server to achieve a better performance. The problem here is not the logger itself. The problem lies again with the sandbox mode of Deno. In order to get timestamps with a higher resolution of microseconds, we must run the application with the flag allow-hr time. This will give access to use specific instructions of the CPU to get high precision timestamps at least in microseconds.